All right, let's just jump right in. We're going to talk about something that can feel a little intimidating in the C programming language: pointers.
And look, let's just be real for a second. They have a reputation, right? This quote really says it all. For a lot of programmers, pointers are where they hit a pretty serious wall.
So what's the deal? Is all that fear really justified? Are they actually going to send electric shocks through your keyboard or something?
Not quite. Seriously though, in the next few minutes, we're going to pull back the curtain and show you that a pointer is really just a simple tool, but one with an incredibly powerful use.
Okay, so if we're going to stop cowering in fear, we have to start at square one. And I mean the real basics, how your computer actually thinks about memory.
Think about it like this. Every single tiny byte of memory in your computer has its own unique number. We call that its address. It's kind of like a super long street where every house has a number. Or maybe like a giant wall of mailboxes, each with its own little label.
So when you write something like int I equals 10 in your code, that number 10, that's the stuff you put inside one of those boxes. But the address, that's the number on the box itself. It's the difference between the letter in the mailbox and the mailbox number.
And that brings us right to it. What is a pointer? Well, it's just a variable that holds an address. That's it. It's like a Post-it note where you've written down the box number for another box. It's not the actual thing, it's just a note telling you where to find the thing.
Okay, so we know what a pointer is. Now how do we actually use one? Let's get into the toolkit.
So there are really only two key operators you got to know. First up is the ampersand, or the address of operator. You stick this in front of a variable, and boom, you get its memory address. Then there's the asterisk, the indirection operator. It does the exact opposite. You give it an address, and it goes and fetches the value that's at that address.
All right, let's actually see this ampersand operator do its thing. Check out this code. We've got our int I equals 10. Now to get its address, we just write and I. That printf line is just a way to show it on screen using %p. What you'd see is some long hexadecimal number, and that's the real actual spot in your computer's memory where I is living.
Now, let's flip it around and talk about the asterisk, the indirection operator. Once you have a pointer holding an address, using that little star in front of it basically turns the pointer into a stand-in, an alias for the original variable.
Okay, let's walk through a full example. We start with int I equals 10. Easy enough. Then we make a pointer called p. Next, and this is key, we say p equals and I. So now p is holding the address of I. And here's the magic. Look at that last line, star p equals 20. What just happened? Since star p is an alias for I, that line just reached across our code, found where I lives, and changed its value to 20. We changed I without even using its name.
So that's kind of cool, right? We can change a variable indirectly, but you might be thinking, so what? Why would I do that? Well, this next part is the big reveal. This is the main reason pointers are so essential in C.
And yeah, that's the million-dollar question, isn't it? If p is just a stand-in for I, why not just write I equals 20 and call it a day? Why all the extra steps?
The answer has everything to do with a fundamental rule about C functions. They work on copies. It's called pass by value. So when you give a variable to a function, it doesn't get your original. It gets a photocopy. So look at this increment function. It takes x, it adds 1, but it's adding 1 to the photocopy. The original variable back in your main code, totally unchanged.
And this is the solution. This is the whole game. Instead of handing the function a copy of the value, we hand it a copy of the address. The function now knows where the original data lives, so we can go find it and change it directly.
Let's trace it step by step. 1. When we call the function with and I, we're getting the memory address of our original I. 2. A copy of that address gets passed to the function's parameter, p. 3. Now, the function is holding the map, the location of the original I. And 4, the line star p equals star p plus 1 uses that map to go to the original spot and change the value. Simple as that.
And just like that, it works. After we call that function, the value of I back in our main program is now 11. We've successfully given a function the ability to reach outside of itself and modify data. This is absolutely critical for building anything complex in C.
All right, so now that you've seen their power, we got to talk about the dark side. Just kidding, but let's cover a couple of super common mistakes you'll want to watch out for.
This one gets everybody at first. It's a tricky syntax rule.
In C, that little asterisk, it sticks to the variable name, not the data type. So if you write int star p, comma q, you might think you made 2 pointers. But nope, only p is a pointer. Q is just a regular old int. To do it right, you have to put a star next to each and every variable you want to be a pointer.
Okay, next up, the infamous billion-dollar mistake, as its creator called it. We are talking, of course, about the null pointer.
So what is a null pointer? It's basically a pointer that points to, well, nothing. It's a special value that says, I'm not pointing to any valid memory right now. And that's fine, it's useful, but the second you try to use it to dereference it with that asterisk, your program is almost guaranteed to crash. It's like trying to deliver a package to an address that's just a blank piece of paper.
Okay, let's do a quick lightning round recap. What did we learn? 1. A pointer just holds a memory address. 2. The ampersand, and, gets you an address. 3. The asterisk, star, follows an address to get the value. 4. The whole point is to let functions change original variables. And finally, watch out for that tricky declaration syntax, and for the love of all that is holy, never, ever dereference null.
So, let's end on this thought. You now know how to give a function a key, a map to a location, that lets it change data anywhere in your program. That's a huge new power. So the question is, what are you going to build with it?